plus 6 equal to 0. And if you multiply with minus sign, because we required the positive lambda values, lambda cube minus 6 lambda square plus 11 lambda, okay, minus 6 equal to 0. Trial and error method, trial and hit method also we can say, means we have to take some values of lambda randomly and substitute here, starting with the value of lambda is equal to 1. But
Okay.
fortunately here lambda is equal to 1 definitely satisfy the above equation. You see, 1 plus 11 is 12, minus 6 is minus 12. So definitely the above expression 0 when lambda is equal to 1, we apply the synthetic division method from here. That is lambda is equal to 1.
Sir, can we do it in the calculator?
Lambda cube, I think square terms we can do it quadratic form, but cubic shayad will try. You can try. If you get the same thing, okay. Coefficients we have to write. But ये work आपको
I
manually examiner को
I
बताना
got
पड़ेगा.
132.
132 is absolutely
अच्छा
correct.
अच्छा.
But I think
Okay.
this working you have to show 1 minus 5.
Okay. Okay.
It's minus 5. That's for your cross verification. You can do it. But I think this work is
Hmm.
compulsory. You have to show to the examiner. It's a lambda square.
Okay.
Otherwise, it's a long answer, no? Minus 5 lambda
Yes.
plus
Yes.
6 equal to 0. Now we can find out the factors here. Lambda square minus 3 lambda minus 2 lambda plus 6 equal to 0. If you can take lambda common, then lambda minus 3 left off. Second, you take minus 2 common, that's minus 3. If you take lambda common, we are left with lambda minus 3. If you take minus 2 common, once again lambda minus 3 is equal to
Yes.
0. Lambda minus 3 will be repeated here. Lambda minus 3 will be repeated. So then left off is lambda minus 2 is equal to 0. So once already we got one lambda value is 1 here. So finally, what we can say, those values are called eigenvalues. Eigen,
Yes.
half of the part this is. कभी कभी खाली eigenvalues भी पूछता हूँ. R
Okay.
lambda is equals to 1, 2, 3. So what do you say? It is non-repeated eigenvalues. Okay. So there are how many lambda values are
Okay.
there? How many lambda values are there?
3.
3 lambda values. So for
3.
each lambda value, you will get eigenvector. So we start with this like this, starting with the case 1, when lambda is equals to 1. So a minus lambda I. So directly we'll do one thing. यहाँ पे ये जो equations आई, we got characteristic equation ना यहाँ पे. Here we should substitute directly lambda values, and we assume our eigenvector is x1, x2, x3. यहाँ पे मैं ऐसा लिख देता हूँ आपको पहले. Let us assume that capital X1 is equals to x1, x2, x3 be the corresponding eigenvectors. So if you put lambda is equals to 1, what happened? Directly lambda is equals to 1. If you substitute, you will get 0, 1 minus 1, 0, already 0, minus 1. This is 1, this is 1, this is 1, this is 2, this is 2, this is 2, into vector is this one, x1, x2, x3 is equal to 0, 0, 0. Okay. Now you see
Yes, sir.
equation number, sorry, row number 2 and row number 3. They are beautiful rows, we can say in maths language. They are called beautiful rows. So
Yeah.
we should convert into the echelon form, this matrix into the echelon form. Then you will get the x1, x2, x3 values. Those x1, x2, x3 are called eigenvectors. So what do you do
Okay.
here? We are going to convert this matrix, this right side matrix, into the echelon form. Echelon form means
Okay.
if the zeros are occurred in that matrix, that should be in increasing order. मतलब first row में अगर एक zero है तो second row में दो zero होना, third row में तीन zero होना. That form we required. यहाँ पे क्या हो गया, पहले रो में first
2
row
0
we got
already.
two zeros. We'll do one thing. We can change it. R1 interchanging with R2. What we are getting here? Tell me. 1 1 1
1 1 1
0
minus 1.
0 minus 1. Okay, R1 and R2 we are
2 2.
interchanging. This is 2, this is 2, this is 2. And be careful that we did not change anything here. X1, X2,
Yeah.
X3, and corresponding 0 0 0 also. Now, our target is to make it this element as 0. So with the help of R1, we
Okay.
can do it. Operation क्या हो सकता है? Can you tell me that?
R2 is equal to R2 minus 2 R1.
एक मिनट, हाँ,
R3, sorry. R3 is equal to R3 minus 2 R1.
मैं थोड़ा सा पेजेस ऐड कर लेता हूँ.
जी.
R3 changes to R3 minus 2 R1.
Yeah.
So after changing, what happened? इसे कंटिन्यू कर लेता हूँ मैं, पेजेस थोड़ा ऐड करने में प्रॉब्लम हो गया. हाँ, so then after changing, you will get the matrix will be like this: 1 1 1 0 0 minus 1. And R3 intentionally we are changing, that is 0 0, and this is also we are getting 0. And here we have
Yeah.
x1, x2, x3 is equal to 0 0 0. Then you see echelon form we have converted, that below diagonal elements are 0 is called echelon form. So then we can go for back substitution. We'll multiply 1 with x1, you will get a equation that is x1 plus x2 minus x3 is equal to 0. It is the equation number 1. Okay na? Matrix multiply
Okay.
1 into x1, 1 into x2, 1 into x3. Here second row, 1 into 0 into x1 0, 0 into x2 0. We may get only minus x3 is equal to 0.
Minus x3.
Minus x3 is equal to 0 implies we say that our x3 value will be 0.
Yeah.
Understood? If x3 is 0, then finally what we are getting? x1 plus x2 is equal to 0. If x3 is equal to 0 means x1 plus x2 is equal to 0. Understood?
Yes, sir.
In this one, we have to assume some vector, that is, suppose if x2 is equal to k, then definitely what about x1 becomes minus k,
K
no?
minus
Some
K.
of these two will be 0. So finally we got our eigenvector. First eigenvector we got it. Our eigenvector is this one, capital X1 equal to x1, x2, x3 is equal to, so the vector we got it as x1 is minus k, x2 is plus k, and x3 is 0, is equals to, if you take k common, we are getting minus 1, plus 1, and 0, which is called the first eigenvector corresponding to lambda is equals to 1. Okay,
Yeah.
case 2, when lambda value is plus 2. Once again, we substitute in that characteristic equation. I am writing directly, you check it later on. 1, 0, minus 1, 1, 0, 1. And this is 2, 2, 1. So now in this case, we have assumed the same x1, x2, x3 will be the corresponding eigenvector. x1, x2, x3,
Okay.
which is equal to 0, 0, 0. Once again, we should convert the right hand side matrix. That matrix should be in echelon form. तो उसके लिए क्या करेंगे, नंबर ऑफ जीरोस को इंक्रीज करेंगे. इसके लिए एक ऑपरेशन है R2 चेंजेस टू, देखिए इसको 0 कर सकते हैं इजीली. R2 changes to R2 plus R1. Can we do it this?
Yeah. Yes, yes.
So what happens is, if you apply this operation, minus 1, 0, minus 1. So 1 minus 1 is 0. This is already 0. Again 1 minus 1 is 0. And here 2, 2, 1. x1, x2, x3 is 0, 0, 0. Now next target is this one, we have to make it 0. The operation will be R3 changes to, याद है शायद ना आपको, R3 plus 2R.
R3 changes. Yeah.
So then this matrix becomes minus 1, 0, minus 1, 0, 0, 0. This is 0. This is 2. R3 is 2 plus 2 into R1 is 0. It's minus 1. x1, x2, x3. 0, 0, 0. Right? Now you see
Yeah.
the elements below the diagonal become 0. अब इसको और 0 करने का ट्राई करें तो दूसरा चेंज हो जा रहा. So then enough up to here. We convert into the equation form and simplify. That if you simplify, minus x1 minus x3 is equal to 0 is the first equation. Okay ना?
Yeah.
This is the equation number 1. Second में तो कुछ भी नहीं मिल रहा. Third is 2x2 minus x3 is equal to 0. This is the second equation. So we should solve these two equations. And if you simplify second equation, can we say 2x2 is equal to x3? Right now?
Yes, sir.
If we assume x2 value is equal to k, then what about x3 becomes? 2k na?
Yeah.
So x2, x3, if you got it, you will get x1 easily. See, minus x1 is equal to x3. Minus x1 is equal to x3 value is already 2k, right?
Yeah. Substitute.
Yes. Minus, if you bring that side, x1 becomes minus 2k. Now our x2, that is corresponding eigenvector, will be x1, x2, x3, which is equal to x1 is minus 2k, x2 is plus k, x3 is plus 2k. Now if you take k common, what we are getting? Minus 2 plus 1 plus 2, which is called the second corresponding eigenvector. Then we have one more left out, that is corresponding to lambda is equal to 3. We must get one more eigenvector. So for each lambda value, you will get one eigenvector.
Okay.
Case 3. When lambda is equals to 3. So we get the matrix will be minus 2, 0, minus 1, 1, minus 1, plus 1. This is 2, this is 2, this is 0. Into, once again, we have assumed that x3 value will also be x1, x2, x3. That's equals to same 0, 0, 0. And the same thing, you have to convert into the echelon form. Means we make it this element as 0. Similarly, this element as 0. So operation is R2 changes to, we multiply R2 with 2 and subtract with this R1. और मतलब ऐड करेंगे 2 R2 plus R1. Operation क्या भी ले सकते हैं आप, it's a compulsory. Whatever I am going to say, you have to take the same thing. It is not compulsory. Our intention to make it below diagonal elements are 0. उसके लिए आप ऑपरेशन कौन सा भी लगा लीजिए.
Okay.
Understood?
Yes, sir.
Minus 2, 0, minus 1, 0, minus 2, and this is 1. This is 0, this is 2, this is minus 1 into x1, x2, x3 is equal to 0, 0, 0. Right? अभी देखिए, और
Yes, sir.
बिलो डायगोनल एलिमेंट्स को जीरो नहीं कर सकते अपन. So we convert into the matrix form. That's the equation. Minus 2x1, there is no x2 value. Minus x3 is equal to 0.
सर R2 लेके कर सकते हैं ना?
कर सकते हैं, यहाँ से भी आ जा रहा होगा.
ओके ओके.
Minus 2x2 plus x3 is equal to 0. This is the second equation. थर्ड इक्वेशन में भी खाली माइनस प्लस का डिफरेंस है, तो जरूरत नहीं, इसको ही सॉल्व कर लेंगे. -2x2 is equal to -x3. Minus and minus sign will be cancelling. It is 2x2 is equal to x3. There is a relation between x2 and x3. So what do you do? We assume x2 as equal to k. If x2 is equal to k, definitely x3 becomes 2k.
Hmm.
And if you substitute here in this equation, minus 2x1 is equal to x3. x3 value is 2k. x3 value is 2k. 2 and 2 cancel. x1 is equal to minus k. Finally, third vector x3 is equal to x1, x2, x3 is equal to x1 is minus k, x2 is plus k, x3 is 2k is equal to k common. -1 +1 +2. So therefore, 3 eigenvectors for corresponding 3 eigenvalues we got. ठीक है, ठीक है ना?
यस सर।
और एक क्वेश्चन है था रिपीटेड आइगन वैल्यूज का, थोड़ा ब्रेक के बाद कराता हूँ। और कुछ डाउट है तो बोलो, वो भी टॉपिक कराता हूँ।
जी सर। कैनोनिकल फॉर्म एक क्वेश्चन आ रहे थे सर, मैं कल क्वेश्चन पेपर में देखा।
देख लेता हूँ कैनोनिकल फॉर्म टू क्वाड्रेटिक फॉर्म।
जी
ठीक है,
सर, वो एक क्वेश्चन। जी।
ठीक है, वो भी देख लेंगे अब एक ब्रेक के बाद।
ओके सर।
वी हैव अनदर सेक्शन। ओके, थैंक यू।
ठीक।